before we start, do we need to clear up anything from last chapter? Anything at all? This man got enough one fat on me. Okay. So we have the atomic theory of matter. If before that, okay? We know what atoms are, right? What are they?
Elements.
The building blocks of matter, and they are found inside an element. Molecules, what are they? Two elements combined together. Ions, what do you think ions are? They are atoms with a net positive or negative charge. Okay? No. Those aren't ions. Those are subparticles of an atom.
You said the molecules are
The combination of two or more atoms. Alright, so the atomic theory of matter. We have somebody named Dalton. Dalton made a couple postulates in order to figure out what exactly are atoms. Alright? He figured that each element is composed of extremely small particles called atoms. We know this, right? He also notes that the atoms are the fundamental building blocks of matter. He also says that one atom of a given element are identical to one another in mass and other properties. For right now, we're going to say that that is true. Couple slides, we're going to see not so much. Right? So for right now, in your element, all the atoms look alike. They're exactly the same. Right? One atom of an element are different from the atoms of all other elements. So what does that mean? All carbon atoms are significantly different from all hydrogen atoms, which are all different from your helium atoms. Right? Atoms of an element are not changed into atoms of a different element by a chemical reaction. What that means is, if you have hydrogen gas reacting with oxygen gas to produce water, you at no point in time will get, instead of water, you will not get carbon dioxide. So you cannot change. So what that means is this. So you have H2 plus O2 gives you H2O. Right? You will never get H2 plus O2 gives you CO2. Alright? This will never happen. So you cannot change, if by a chemical reaction, you cannot change one atom into another. Atoms are neither created or destroyed in a chemical reaction. Meaning, if you start out with a certain amount of atoms, if you put that amount of atoms in, you must get that amount of atoms out. Yes?
Is it H2 plus O2 or just O?
What?
The equal to water, yes.
This
This is what? This oxygen gas or just one molecule of oxygen?
No, oxygen gas. Don't worry, we'll get to that in chapter 3. Okay? We ain't there yet. General stuff for right now. Okay? So, atoms are not created or destroyed. So, going back, linking to what Ronnie just asked. How many hydrogen atoms do you have here?
2.
How many oxygen atoms do you have here?
2.
How many hydrogen atoms do you have here?
2.
How many oxygen atoms do you have here?
1.
So something's missing.
One oxygen.
You're missing one oxygen. So what this means is that you start out with 4 atoms altogether, but you came out with 3. This is not possible. So you have to now do something to make sure that everything balances out. What you put in is what you get out.
That's very math.
Say it again?
It's a math.
It's a concept. It's a concept. You're going to get to that concept next chapter. Okay?
So it's supposed to be 2H2.
So it's supposed to be 2H2
Two is
there. Okay? So now, how many hydrogen atoms do you have?
4.
Oxygen atoms? Oxygen atoms? Oxygen atoms. Culture. Okay? 2 hydrogen atoms? 4. So now, what you put in is what you get out. Okay? Yes.
You know how oxygen, right? Like O is just an oxygen atom and O2 is oxygen gas.
Yes.
Does the same go for hydrogen? Like H is just a hydrogen atom and
Yes.
O2 is hydrogen gas.
Yes.
Is that for everything or not?
Yes.
That's for everything in the
Well,
picture? No.
No,
Okay, no.
because you don't have gases for, not all of them is a diatomic gas. So helium, for example. Helium is a gas,
That's not a diatomic.
but it's not diatomic. Right? You mind me to ask something?
Professor, just curious, S2 plus O2 gives H2O, but plus O, would that happen?
Plus O?
Yeah.
No.
No. Yeah.
Right? Compounds are formed when atoms of more than one element combine. Okay, you know this. Oop. Alright? So now we're going to go deeper into what an atom is itself. Okay, the components of an atom. We have 3 components of an atom. We have the electron, we have the proton, and we have the neutron. Okay? Your proton and your neutron, they bind together tightly to form your nucleus. Right? Now your electrons are orbiting your nucleus. Okay, so they're on the outside of your nucleus. Alright? So now what is the charge on a neutron?
Neutral. Is none.
Neutral or 0.
Zero.
Right? What's the charge on the proton?
Positive.
What's the charge on the electron?
Negative.
Good. Right? So now what's the charge on your atom?
Neutral. Neutral.
It's neutral. Why is it neutral?
Neutron is a sub-neutron, electron and proton, combined, so they neutralize.
There you go. So your electrons and your protons are going to cancel out each other. Alright? Alright, so this goes back to why all your elements on your periodic table are also neutral. So think about it, alright? If you have all the elements are neutral on the periodic table, right? Can we explain why based on what we just talked about?
All the elements are
All the elements are neutral.
radioactive.
No, we ain't talking about the radioactive stuff. They're still neutral, but they are radioactive, right? So why is it that you do not have a net charge of the elements on the periodic table?
It means they have an equal number of protons and electrons and they cancel each other.
There you go. You have the equal number of protons and electrons. Okay? Now, here's for examples. The electrons, they have the symbol of a common E with a negative sign up top. Charge is -1. This is the mass of an electron. What can you tell me about the mass of an electron, protons, and your neutrons? What are they?
Very small.
They're very small. Look at the exponent. -28, -24. Alright? What we need to know, we don't need to memorize down the masses. what we need to know mainly is the location of your electrons, protons, and neutrons. Your electrons is on the outside. Your protons and your neutrons is on the inside of your atom. Your proton has three possible symbols, a P, P plus, or an H plus. What is H?
Hydrogen.
Hydrogen plus. Hydrogen plus is a proton. Alright? Neutrons is lowercase n. Now, all of our elements have their own particular symbols. Alright? Every one of them, none of them has the same symbol. The symbol can either come as one uppercase letter, or one capital letter, or a capital letter and a common letter combined. Right? For example, carbon. Carbon has the symbol C. Nitrogen has the symbol N. Calcium has the symbol Ca. Sodium has the symbol Na. Right? Compounds are pure substances made up of two or more different kinds of atoms. For right now, what we're going to be doing, I'm going to teach you how to read a chemical formula. Okay? You're going to see these subscripts. You can just take these right here. Alright? Your subscripts are going to be to the right of a particular atom. That subscript is going to tell you how many of these atoms are present in the atom before, the symbol before it. So here, this subscript here tells you that you have 2 hydrogens. Here, 2 oxygens. Here, 2 hydrogens. If you do not see a subscript, that means it's 1. Did we get that?
Yeah.
Okay. Here, compound formulas, all we're going to be doing is combining 2 atoms together. You have carbon and oxygen. When they combine to make a compound, it is called carbon monoxide. When sodium and chlorine come together to form a compound, you have sodium chloride. So, tell me? No? Okay, how many count? How to count the number of atoms in a compound? Here, how many atoms of each, and how many atoms in total are there in water? 2 what? No. 2 hydrogen atoms, 1 oxygen, in total 3. Oxygen gas, 2 oxygen, 2. Carbon dioxide, 3 total, 1 carbon, 2 oxygen. Methane, 1 carbon, 4 hydrogens, in total 5. Hydrogen peroxide, 2 hydrogens, 2 oxygen, in total 4. Do we get that? Yep.
You know how, like in the slide it says for subatomic particles, that the mass of an electron is like so small that it's ignored,
Okay.
but an electron is what makes the isn't an electron what makes the ion an anion or a cation?
Yes, but we're not talking about that.
Oh, in terms of
Like,
that's
But no, it's like we're off from that. We haven't gotten there yet. Okay, so let me give you an example of what these things look like. Okay? Your electrons take up a massive amount of room as compared to your nucleus. Let's say my clicky thing is my nucleus. The circumference of this entire room would be the orbit of your electron. So So your electron is going to take up that much space as compared to the nucleus. Okay? Alright, continue that. Alright, so here's what I'm going to give you. I'm going to give you a name. I'm going to give you the amount of atoms that you have present in this particular compound. And you are now to give me the formula. Okay? All you have to do for the formula is to read what you see. Your subscript will come after your symbol. If you have a subscript of 1, you do not have to say the 1. Alright? So we have nitrogen dioxide. Nitrogen dioxide has 1 nitrogen atom and 2 oxygen atoms. What is the formula? NO2. That's what I got 2. Next, sulfuric acid. Sulfuric acid has 2 hydrogens, 1 sulfur, and 4 oxygen atoms. H2SO4. Phosphoric acid, 3 hydrogens, 1 phosphorus, and 4 oxygens.
H3P4.